Hello students, this is my lecture number 26, Atomic Structure class plus 1, and in this lecture I am going to show you how to fill orbitals. That is, I am going to talk about electronic configuration of various elements. This is now a very interesting part. I am going to start with hydrogen. Atomic number of hydrogen is 1. Now see, we know that in an atom we have shells. In shells we have subshells, and in subshells we have orbitals, and orbitals are having electrons. So we need to reach up to orbitals, and quantum numbers are used to identify various orbitals. Now if I consider hydrogen, we have only one electron. This is a single electron system, and definitely the first electron will present in the first main shell. इसका मतलब हाइड्रोजन के लिए n is 1, okay, because the first shell is having minimum energy and shells are filled in the order of their increasing energies. So I will say that in the first shell we have the same subshell, and that is having one orbital, that is 1s. Since electrons are present in orbitals, so I prefer to write it as 1s1, which shows this is shell, this is subshell or orbital having one electron. So I can also represent it like 1s1, and by convention we assign clockwise spin to the first electron. Is that clear? If I take helium, atomic number 2, now we have 2 electrons, and what is the capacity of first shell? First shell can accommodate 2 electrons. So second electron is also present in the first shell or 1s subshell and 1s orbital, because shell भी वही है, subshell भी, क्योंकि एक में कोई differentiation नहीं होगा ना. So I can write this to be 1s2. So hydrogen is written as 1s2. First spin is clockwise by convention, second is anti-clockwise. तो ये कन्वेंशन को हम फॉलो कर रहे हैं. कई बार स्टूडेंट्स पहले स्पिन एंटी क्लॉकवाइज बना देते हैं, वो गलत नहीं है, बट कन्वेंशन को फॉलो किया जा रहा है. सो यू कैन वेल डिफरेंशिएट हाइड्रोजन इज 1s1 एंड हीलियम इज 1s2. नाउ एन ऑर्बिटल कैन अकोमोडेट एट द मोस्ट 2 इलेक्ट्रॉन्स. इट मीन्स फर्स्ट शेल इज कंप्लीटली फिल्ड. नाउ आई मूव टू थर्ड एलिमेंट, lithium, atomic number 3. Now if atomic number is 3, first shell is filled, second electron will definitely go to second shell. And how do we decide? Second shell means after filling of 1s, second shell will come. That is given by n. Higher the value of n, higher is the energy. But in second shell, for multi-electron system, we have 2 subshells, 2s and 2p. Now which subshell is having higher energy or which subshell is having lower energy, because electron will go to the subshell which is having lower energy. So that is decided by a principle known as Aufbau's principle. According to this principle, in case of multi-electron system, subshells oblique orbitals are filled in the increasing order of their relative energies, and relative energy is given by n plus L rule. Now you can see, if you want to distinguish between 2s and 2p, 2s, this is n, s is L, fine. 2l for s, L is 0, so this is 2 plus 0 is equal to 2, and for PL is 1, so 2 plus 1 is 3. Now you can easily answer which is having lower energy, that is 2s. It means out of 2s and 2p, it is that 2s which is going to be filled. So for lithium, I will write it as 1s2, 2s1, right? अब ये इलेक्ट्रॉन यहाँ आ रहा है. So this is 1s2, 2s1. Since first shell is completely filled, I may write it like as helium, जो first shell complete हो चुका है, ठीक है, noble configuration आ चुका है. तो I can mention it in the terms of helium, helium 2s1. This is your sole discretion, ये आपकी मर्जी है. Okay, then beryllium 4. Yeah, very clear. Still we have capacity of one more electron here, so I will write this to be 1s2, 2s2, right? So this is 2s2, or helium, first shell khatam ho gaya, 2s2. Is that clear? Then boron, atomic number 5. Very easily. दोनों में से जो आपको अच्छा लगता है, वैसे कन्फिग्रेशन ऐसे लिखी जाती है अंडरस्टैंडिंग के लिए. बोथ आर गुड. 1s2, 2s2, s is filled now. 2s3 is not possible. Orbital can have only 2 electrons. Then definitely it goes to the next subshell or orbital, that is 2p. 2p is what? Subshell. Now let me clarify this. I can mention it as 2px, 2py, 2pz, and all of them have same energy. Why? Because these are degenerate orbitals, and energy for multi-electron system, that is relative energy for multi-electron system, is given by n plus L value. So n plus value for all of them is same. Now for boron, I can write it to be 2p1, or more precisely it is 2px1. So I'm giving first electron to the x. You can give it to y, z, but conventionally I'm giving it to x. So this is 2px1. Then question comes for 6, atomic number 6. 1s2, 2s2, 2px. Now again problem begins. Earlier हमने क्या किया, orbital को fill किया, then we move to the next one. But now the problem is that we have 3 orbitals of approximately same energy, known as degenerate orbitals. अब यहाँ क्या करना है? In order to answer this, we have a rule known as a Hund's rule of maximum multiplicity. This rule says, if we have a possibility, if we have a case where orbitals have approximately same energy, then give 1 electron each to the orbital with same spin. Okay? Why? Because all of them are having same energy. So we cannot differentiate. भाई इसको 2 electron देंगे फिर इसको. Because this is again energy considerations. All of are having same energy, so assign 1 electron to each orbital, right? And then do the pairing. So according to this rule, electron pairing will not occur unless each atomic orbital of approximately same energy contains a single electron with same spin. तो यहाँ हम बच्चों को सम्स देते हैं, confusion को दूर करने के लिए इस बात को सीखना होगा. So in case of carbon, second electron goes to 2py. So instead of now writing 2p2, it is better to mention it as 2px1, 2py1, because मैं orbital तक filling दिखा रहा हूँ. And spin multiplicity, maximum multiplicity क्यों कहते हैं? This is giving minimum energy to the system. एक ही ऑर्बिटल में दोनों इलेक्ट्रॉन आएंगे तो रिपल्शन होगी. अब क्या है, 3 ऑर्बिटल हैं, उनमें सेम एनर्जी है, एक इलेक्ट्रॉन दे रहे हैं टू मिनिमाइज रिपल्शन. वो हम कंसिडर करते हैं स्पिन से. जैसे मैं नेक्स्ट केस में आपको स्पिन बतलाता हूँ. फॉर नाइट्रोजन, एटॉमिक नंबर 7, दिस इज 1s2, 2s2, 2px1, 2py1 and 2p Z1. I think this is clear to you, 2pZ1, because Hund's rule is being obeyed. Okay, I hope so this is clear. तो अब मैं स्पिन की बात करता हूं आपसे. 3 इलेक्ट्रॉन्स हैं, 1 2 3, 1 2 3. पहले इलेक्ट्रॉन की स्पिन क्लॉकवाइज मानते हैं. दिस इज 1/2. So if all are clockwise, all are having spin plus 1/2. What is its total spin? 3/2. So spin is high. If I do filling like this, first electron, second, third, now plus 1/2, minus 1/2, plus 1/2. This will cancel out. Spin is 1/2. Spin is less. तो अब आप समझ सकते हो मैक्सिमम मल्टीप्लिसिटी, मैक्सिमम स्पिन की बात करते हैं हंड्स के द्वारा. तो होपफुली दिस इज क्लियर. देन कम्स 8, ऑक्सीजन. यू कैन इजीली आंसर नाउ. 1s2, 2s2, 2px2, 2py1, because of pairing will begin. This electron will come here. 9, 1s2, 2s2, 2px2, 2py2, 2pz1. Yeah. Is that right? And 10. This is 1s2, 2s2, 2px2, 2py2, and 2pz2. Or I can simply write this to be 1s2, 2s2, 2p6. 1s2, 2s2. Let me rub this. 1s2, 2s2, 2p6, because subshell is completely filled, and this is a configuration of a neon. So very easily you can understand that how we do the filling of subshells or orbitals. And see that in case of lithium we have one unpaired electron. Now you should know what is valence shell. Valence shell, outermost shell is known as valence shell. See, if I take carbon, which one is the valence shell? This is the valence shell. I'm talking about shell. ये shell होता है. Valence subshell is meaningless. Valence shell. There are 4 electrons in the outermost shell. Valence shell. So its valency is 4. In case of nitrogen, we have 5 electrons in the valence shell. 2, 3, 4, 5. Now it cannot lose 5 electrons, but it can gain 3 electrons. So valence shell is having 5 electrons, but its valency is 3. Then oxygen, you can see this is the valence shell. Counted 2, 2, 1, 1, 6 electrons in the valence shell, but its valency is 2 because it can gain 2 electrons. Exactly in halogens, we have 7 electrons in the valence shell. It is running short of 1 electron to complete its octet, outermost shell. So its valency is 1. So that is how we find its valency. Now you can see that there are certain elements which are completely filled. Like if I take beryllium, what is the configuration of beryllium? 1s2, 2s2. अगर हम beryllium को देखें 1s2, 2s2, if you want to find its spin, plus 1/2, minus 1/2, because these are paired. Plus 1/2, minus 1/2. So 1/2, 1/2 से cancel out हो गया. तो what is the next spin in case of beryllium? 0. No unpaired electron is there. मैं ये बात इसलिए कर रहा हूँ क्योंकि मैं आपको प्रीवियस लेक्चर में बता चुका हूँ कि एक एटम में इलेक्ट्रॉन्स हैं. जो इलेक्ट्रॉन है दैट इज रिवॉल्विंग अराउंड द न्यूक्लियस, राइट, विच बिकॉज न्यूक्लियस इज अ चार्ज्ड बॉडी, इलेक्ट्रॉन इज अ नेगेटिव चार्ज्ड बॉडी. ड्यू टू इट्स रोटेशन it generates electric field, which in turn produces magnetic field. Okay, so that system behaves as a bar magnet, mini magnet, micro magnet, because that has magnetic field. Now the magnetic field is generated because of two reasons: one, orbital motion, and second one, spin. spin of electron. So there are two reasons due to which magnetic field is generated. One is due to orbital motion and second is spin motion. It means whether that system behaves as diamagnetic or paramagnetic, that depends upon the number of electrons. Let me tell you what are diamagnetic substances. Those substances which are generally repelled by the external magnetic field. Okay, at this level I want to say that if you see beryllium, there is no unpaired electron, right? Because net spin is 0. So species, atoms having no unpaired electron will have net 0 spin magnetic moment, 0 magnetic moment, and these substances are repelled by external magnetic field. So beryllium is diamagnetic because it has no unpaired electron. So those species which have no unpaired electrons are generally repelled by the external magnetic field, and these species are known as diamagnetic. And those species which have unpaired electron, like you can see that if I take lithium, there is one unpaired electron in case of lithium. Okay, those species, I am talking about atoms only. तो इसको हायर लेवल में क्लास में हम मॉलिक्यूल्स पे लेके जाएंगे, देन थ्योरी विल चेंज. तो हम एटम्स की बात कर रहे हैं कि जिनके पास अनपेयर्ड इलेक्ट्रॉन्स होते हैं, उनके पास नेट मैग्नेटिक फील्ड होती है, and they are attracted by the external magnetic field, and they are known as paramagnetic substances. So the very basic information, what are diamagnetic or what are paramagnetic substances? Diamagnetic substances are substances which have no unpaired electron, basic knowledge, and paramagnetic substances which have unpaired electrons. So diamagnetic substances are repelled by external magnetic field, whereas paramagnetic substances are attracted by external magnetic field. Now I have mentioned electronic configuration up to atomic number 10. Now easily we can go up to atomic number 18. Let us finish this here. Now atomic number 11 is sodium, 12 is magnesium, 13 is aluminium, 14 is silicon, 15 is phosphorus, 16 is sulfur, 17 is chlorine and 18 is argon. यहाँ मैं 1 डाल देता हूँ. 11, 12, 13, 14, 15, 16, 17, 18. Is that fine? Now you can easily answer this question. If it is 11, it is filled up to 10, 11th. Obviously, second shell is completely filled. The electron will go to the third shell. So hopefully you have got my knowledge, my information. 1s2, 2s2, 2p6, 3s1. Yeah. And preferably this is neon 3s1 क्योंकि शेल completely fill हो चुका है, थर्ड पीरियड में चले गए. तो इसको हम जो सेकंड कंप्लीट हो चुका है उसकी सेंस में लिख सकते हैं, राइट. सोडियम ऑब्वियसली दिस इज, मैं शॉर्ट फॉर्म में लिख रहा हूं, आप इट्स अप टू यू. नियॉन 3s2, दिस इज फॉर मैग्नीशियम. एल्यूमिनियम नियॉन. अब आप आगे इजीली वर्क कर सकते हैं. नाउ आई एम गोइंग टू अप्लाई 3px1 here, and for 14 this is Hund's rule which is going to decide filling. 3s2, 3px1, 3py1. So electron comes here, right. Then phosphorus neon 3s2, 3px1, 3py1 and 3pz1. So this is your phosphorus. Sulfur neon 3s2, 3px1 से अब 2 हो जाएगा, 3py1, 3pz1. So simply this is pairing. Then neon, this is atomic number 17, 3s2, 3px2, 3py2, 3pz1. And finally, last but not the least, neon, 3s2, 3px2, 3py2, 3pz2. Or this is neon, 3s2, 3p6, because subshell is completely filled. Now you have got a good idea about rules of Bau's principle and Hund's rule by this way. So this is up to atomic number 18, and in my next lecture you will get up to 30, right? So easily we can build up periodic table with the help of this. Thank you very much.